Hello and welcome to my presentation. My name is Simon Dennis and today I'm going to be talking about memory for wear using smartphone data. My collaborators on this project were Elizabeth Valaberte, Adelaide McKenzie, Youngwook Yim and Benjamin Stone. In 1984, Ronald Cotton was convicted for 2 counts of rape and 2 counts of burglary. He was sentenced to life plus 50 years. Cotton was exonerated in 1995 after spending over 10 years in prison when DNA evidence demonstrated that it had been Bobby Poole who had committed the crime. Now, this is a famous case in the memory literature because the victim, Jennifer Thompson Canino, pictured here, on 2 occasions provided a misidentification. So in an original in-person lineup, she picked Cotton. And then in a subsequent retrial in 1987, when Bobby Poole was actually brought into the courtroom, she picked Cotton again. So even though the actual rapist was right in front of her, she picked Cotton. And so this is a demonstration of how choosing a certain person or a certain object can influence people's subsequent memory. But there's another important aspect of this case which is often overlooked, and that's that Cotton gave a false alibi. So instead of remembering where he was at the time of the crime, he recalled where he was the week before. And so as a consequence of that, his alibi didn't check out. And so that was also a contributing factor to the fact that he was convicted. But how reliably can people remember where they've been? What factors affect that memory? And what questions might a detective have asked to uncover the false memory? So these are all very relevant questions from a forensic point of view, but they're not ones that we can readily use laboratory paradigms to answer. So in the laboratory, we manipulate things like font colors and you know, we have different kinds of fractal images and so forth. And so there are certain things we can manipulate. We can discover general principles of memory. But in this case, we really need to know the specifics of what is, how likely is a memory for where, or a memory for when, or for a memory for a person likely to be an error. So we conducted a study where we had people go out with a app on their phone, which recorded a number of different data sources. So it recorded GPS. It recorded small segments of obfuscated audio, and it also recorded accelerometry. Now, this was done using the Unforgettable Research Services system, and the Unforgettable system then takes that raw data and processes it in a number of different ways to create a representation of the different events through which people go. So on the right-hand side, on the left-hand side, you see the app. On the right-hand side, you can see some of the events that have been captured by Unforgettable. So from the GPS, for instance, we're able to identify the address. We're able to get street view images and so forth to get a sense of what people might have been looking at. We're able to establish what the weather was like and so forth. So all of these sources allow us to create a more complete picture of the experience of the individual. In our first experiment, we had 57 participants, and as I mentioned, we collected accelerometry. This was done 10 times a second continuously, and for 1 month. And so that leads to about 51 million data points per participant. We had GPS coordinates every 10 minutes, so about 8,640 pairs per subject. And then we had these short audio segments. So they're short to stop from recording people's conversations and compromising their privacy. And so these were collected as null frequency capsule coefficients every 10 minutes or so. There was a 1-week retention interval, and then they received a memory test. In the test, they received a series of trials like this. So they were given a time. So down here at the bottom, you can see the time. In this case, it was Thursday morning, 8 AM on August 15th. And they were given 4 pins, and they had to identify which of these 4 locations they had been at that time. all of the locations were taken from places they had actually been during the collection period. So they had to distinguish between when it was they were at that particular location. Now, when we did this, the people were accurate 64% of the time. Now, what we did is we ran a conditional logic model in order to establish how important each of the different aspects of the event that we recorded were to people's choice behavior. So unlike a normal logic where you just have a set of predictors and you're trying to produce a consistent outcome, here each of the choices has its own set of predictors. And so what we're interested in is the weighting of the predictors. And these are Bayesian credible intervals, 95% credible intervals around those conditional logic parameters. And so you can see, and perhaps not surprisingly, that GPS has a much larger impact than, say, either the audio or the accelerometry. I should mention the reason that these beta weights here are negative is that we took the distance from the correct location to the location of each of the alternatives in these different spaces as being the predictor variable. So for GPS, for instance, we would say what's the Euclidean distance in the GPS space between the correct alternative and each of the alternatives, and they would be our predictors. So therefore, big negatives will be indicated because a larger distance should make it less likely that you're going to be confused about that point. We also ran a conditional logic using categorical time. So we can do it with time, and we did that. But we also did it by looking, scoring the predictors in terms of whether they were on the same day, hour, and week as the original event. So, so the day column here, or day variable here, would indicate that this the event that they mistakenly said was the correct one was exactly a complete week out. So it was on the same day, but the wrong week. The hour means it's the same hour, but the wrong day, and the week just means it was in the same week. So you can see here that all of these variables were very significant in terms of their impact. So here's the 0 mark over here. But this day error where people give the right day but the wrong week was the strongest of these. And so this is the error that Cotton made. So in experiment 2, we looked to expand upon this by looking at the impact of people's emotions as they were engaged in their everyday lives. So this time we had 67 participants, 14-day collection period this time. And we used Unforgettable as we did in the last experiment, but we also used SEMA 3 app. And so SEMA 3 allows you to query people throughout the day, and we queried them on 11 discrete emotions. So for instance, how anxious do you feel right now? And they had to make a rating on a 0 to 100 scale. We ran the same kind of experiment as last time with the 4 locations, and they had to choose amongst those. And this time people were accurate 67% of the time. So what we can do is that same kind of conditional logic model. And so what we're looking at is to what extent are 2 events more confusable in memory if they have a similar emotional profile. And so we can look at this for each of the emotions, and you can see that in all cases, the results are highly significant. So people's emotional states really do seem to make quite a significant difference to the likelihood of them choosing a similar state. There's a little bit of a stronger effect for the positive emotions than the negative emotions, but nonetheless, strong effects across the board. What was perhaps more surprising was what happened when we did a more traditional logistic regression, where we looked at the relationship between sets of predictors and the likelihood of an error. So here we're not looking at the choice behavior in terms of which options did they choose, but just were they correct or were they incorrect. And so we joined a number of discrete emotions together. So we had low positive, so that would be things like content or relaxed. High positive, so that would be things like happy or excited. Negative low, so that's things like disappointed or bored. And negative high, so that's something like angry. Now, unlike the laboratory data, what we found was no effect for negative emotions. So typically it's the negative emotions that drive effects in the laboratory, but not so when you go out into the real world. The results for the positive emotions were much more interesting. So here we see a positive effect. So it was the higher they rated their emotions like content and relaxed, the more likely they were to get it correct. And conversely, if they rated a emotion like excited highly, they were less likely to get the trial correct. So this is really interesting and a little bit counterintuitive. What we think is going on with the positive low event is that people are experiencing those kinds of emotions when they're in high probability locations, so things like home and so forth. And therefore, there could be a bias towards responding with those kinds of locations. Why it should be that the positive high event would show a negative effect, though, is much more puzzling, and we don't have an answer for that at this point. So in conclusion, after a 1 to 5 week retention interval, people are able to identify where they were about 2/3 of the time. And we have the second experiment was a replication on the first in that regard. Distractors that are similar in location or similar in categorical time are more likely to be chosen. And distractors that have similar emotional context are more likely to be chosen. The negative emotions at the time of encoding do not seem to predict accuracy. But however, low arousal positive emotions are associated with better accuracy, and higher arousal positive emotions are associated with worse accuracy. So to go back to the more applied relevance of this question, what should detectives be asking? So Cotton, you may recall, recounted where he was on the wrong week, and thus led to a false alibi. And our data seems to support that that's a dominant error. So it is the case that people are likely to mistakenly choose the right day but the wrong week. But in addition, the days before and after, and just the week in general around the event are also important. So if you're a detective, it would be a good idea to be asking not just about the time that the crime actually occurred, but about that time, the previous week, that time on days around that as well. And that may uncover some additional errors. Now this of course is just scratching the surface. There's a lot more work to be done, but I think what this does is it demonstrates how we can use experience sampling data to build a much more quantitatively rigorous and translationally relevant memory science. If you're interested in the kinds of technologies that we were using here and potentially using them yourselves, I'm actually the CEO of Unforgettable Research Services, which is a company that we've set up to help people to implement these kinds of technologies. And so the app and a bunch of other sources are available. So if you're interested in that, head on over to www.unforgettable.me and you can find out more there. So thanks very much for your attention.